Bienvenidos, queridos seguidores de Cocodrilos del Mundo, por el canal de Río Verde en YouTube. En esta oportunidad vamos por primera vez a hablar del aligátor mississippiensis, especie de cocodrilo que se encuentra únicamente en los Estados Unidos de Norteamérica. Tendremos el gusto de conversar con Miriam Boucher, y es canadiense, es una bióloga egresada de Clemson University y en estos momentos se encuentra realizando sus estudios de doctorado en la misma universidad. Miriam tiene una amplia trayectoria en el estudio de cocodrilos. En los últimos años estuvo colaborando mucho con la doctora Marisa Telles, con quien hemos realizado 2 episodios de Cocodrilos del Mundo en el pasado. Trabajó con ella en Belice y actualmente dentro de sus estudios de doctorado está enfocada a analizar la dieta de los alligators y los contaminantes que pueden tener estos cocodrilos en su organismo, debido a que algo muy interesante es que mucha gente quizás no lo ve. Algunos ríos de los Estados Unidos se encuentran contaminados por, bien sea cualquier tipo de producto, metales pesados, agroquímicos, por ejemplo. Entonces Miriam está enfocada a analizar la dieta, hace un estudio de contaminación en la dieta y también hace un estudio sobre qué está pasando con los cocodrilos que se alimentan de estos posibles animales contaminados. No solamente se está limitando al área de la universidad donde ella trabaja, sino que tiene un grupo que a lo largo de los diferentes estados donde se distribuye el aligátor mississippiensis en los Estados Unidos, principalmente en la costa que da al Golfo de México, le están colaborando con la obtención de data para este estudio en particular. Well, dear friend, in this opportunity we start to talk about alligator in United States, and we are very happy that a good friend, Miriam Boucher, accepted this invitation to Crocodile of the World. Miriam, welcome. Please talk about your work with alligator or crocodile, because I know that you worked for many years in Belize with acutus and more related, but now you are making your PhD with alligator.
That's right. Thanks for having me, Alvaro. I really appreciate it. So, like you said, when I got started, I didn't start with alligators. I actually started with crocodiles. So I worked with a very good friend of mine, Dr. Marisa Telles, and I was in Belize for about 5 years. And so we did a little bit of everything. So from capturing and tagging crocodiles for mark recapture work to rescuing displaced crocodiles. We worked with the Belizean government a little bit to try to support them in their management activities. And during those years, we also collected samples for other researchers for ecotoxicology work. So I think many people will clip the scutes of crocodiles to mark them, but also keep those samples to look at things like heavy metals or pesticides, different contaminants. So I helped collect a lot of samples and also draw blood. And then that's kind of related to what I'm doing now. So after Belize, now I'm doing my PhD in South Carolina. I'm at Clemson University and with the James C. Kennedy Waterfowl and Wetlands Center. And my project is a regional project looking at alligator diet and toxicology. So because alligators are managed here and their populations are pretty large, there's hunter harvest of alligators throughout the US. And so by working with live alligators and alligators that are hunted legally, we're able to collect samples from 8 different states, so across the whole range, to look at the diet. So we collect stomach contents through stomach flushing or collecting the whole stomach from harvested alligators. And then we also collect blood and muscle so that we can look at mercury and forever chemicals, PFAS, in alligators as well, to see if we can build a profile for these contaminants in alligators, not at a state level, but across the whole region. And then we're doing an exploratory study where we take the stomach contents after we look at all the diet items and we digest all the organic material out of it. And then we're looking for microplastic in those samples to see if alligators could be an indicator species for microplastic in these wetlands. It's been a lot of fun. We work with collaborators all over the US, and then of course still get to talk to my friends abroad like you and other people and get their expertise. And one of the fun things that we did is to be able to stomach flush crocodilians or alligators, you have to put something in their mouth to hold it open. And so usually you use a piece of pipe that's round like this, but it's made of plastic. And for us, we wanted to do something that was a little bit different, so we didn't have the plastic in the mouth. So we worked with Luis Sigler at the Dallas World Aquarium, who does a lot of stuff with Orinoco crocodiles. Yeah. He had designed a square device that holds the mouth open, and I worked with him and used his design to create this jaw prop. It's made of metal and it's square, but you can adjust it up and down, and we use that now to hold the mouth of the alligators open. But because we can see more of the mouth now, we're making all kinds of interesting observations about parasites in the mouth, so certain leech species that are using the tongue of the alligators to feed when they're juveniles, finding pentastome parasites in the soft palate while the alligators are still alive. So it's been a very useful tool for us. And yeah.
Yeah, it's very useful because one of the difference with the common methodology that we try to obtain the stomach content, it's like you say, it's a tube of plastic that you don't see what happened in the mouth inside.
Right.
Right? And now with your tools, it's completely open. You can evaluate everything, like you say. But something important, Miriam, is to explain the people that see this episode. You are working with wild animals under wild harvest season every year in different states.
Yes. So the way it works with alligators here is the sustainable use model in the US is a little bit different than it is for certain other crocodilian species, where the wild harvest may tend to be more the recovery and harvest of eggs to bring to farms or ranches to raise. In the US, the states that allow hunting, it can either be recreational or it can be commercial. Each state's laws are different. So some states like South Carolina, there's only 1,000 permits around that are given each year for alligators to be hunted. And of those people who receive those tags, usually between 300 and 400 alligators are harvested. Whereas in Louisiana, they have a recreational and commercial season. A lot of the alligators that are harvested aren't eaten or used by the hunter, but sold for skins and meat. On a commercial level, those hunters may harvest 200 or more alligators per person per season. And so it's a little bit different. The scale of how many alligators are harvested per state is very different among all of the states. And it's really highly regulated. So to be able to hunt, you must have a permit, and each alligator that is hunted, there's a tag that you're given that you have to put through the tail after they're harvested to make sure that that alligator, from the moment it leaves the wild, is accounted for and tracked through the system, whether it's going to your home or going to a business that sells alligator products. And so it's an interesting system.
Yeah, but, okay. But you're collecting samples for hunting animals and also animals that don't be died, no?
Right.
You can make a difference between, I don't know, if they are hunted or not. You are working with this big, I don't know, space or
Yes. So some states, like I said, some states, for example, North Carolina, no hunting is allowed. So all of our samples from North Carolina come from live alligators that we have to catch and process and release live.
Yeah.
And then in some states, there's a small amount of alligators that are harvested. And if you're only dealing with hunted alligators, you're not getting any samples from protected areas. And most people who are hunting alligators want the biggest alligators. So you also have a bias in what size of alligators are being hunted. So by
Yeah.
working with live alligators, we can cover the whole size range.
Yeah.
Because it is possible to stomach flush alligators that are, 3 meters or more long, but it's much more difficult. But that size of alligator is much more common from the hunter-harvested alligators. So I usually catch and stomach flush live alligators that are under 3 to 3.5 meters in length. And then I get those larger alligators that are 300 centimeters total length and greater from the hunter-harvested samples. It's easier for me to do that than to try to lift a 500-pound alligator on a spine board and stomach flush it. So by using these two methods, we can get all of the range of sizes of alligators, but we can also get alligators from urban areas, from public areas, and then from private areas like private reserves or protected areas. So we're kind of able to cover everything.
And also, it's not a matter between males or females. You capture everything.
We capture everything.
Okay.
Yeah.
And also, you capture in particular season of the year or along the year?
So we kind of do it all year. The hunter harvest in the US is generally in the fall. So starting in August through October. So our hunter harvested samples come from the fall, but our live alligator captures, they begin to be more active in the spring.
Okay.
And then in the summer, the daytime temperatures get extremely high, so they're less active during the day. So we do catch alligators in the summer, but at night. Most of the time in the spring and the fall, we can do it during the day. But so then we use starting from May to October to catch live alligators.
Okay. And I don't know why I remember, because I remember that you published a paper about the plots, no, the marks plot in the tail.
Yes, the spot patterns, yeah.
Spot pattern, you remember? I remember that you do it in Belize. I make the same work based in your paper with intermediates. Are you doing the similar with alligator or it's not available?
So you can't do it with alligators. Unlike crocodiles, alligators, their patterning is much different. So when they're young, they have these really beautiful bands of color on their tail. But as they grow older, that pattern and that coloration goes away. They become more of a solid, darker color. So we can't use spot patterns like the way that you and I did for alligators. There may be potential to use some of the scale patterns of the osteoderms on the back of the alligators, but the patterning on alligators is generally pretty consistent, unlike intermedius and acutus and some other species that have very variable patterns. And so it's harder to identify alligators visually using those techniques. It's not impossible, it's just a little bit harder to do. So we use scoot clips where we cut the tail to mark them, and that is usable because they're a little bit more bold. They tend to sit up at the surface longer and on land, so we're able to visually identify them using that.
Oh, very interesting, very interesting. And what is the future of Miriam Boucher?
That's a good question. Right now, I'm just trying to get through this project, but what I'm hoping is that I'll continue to be involved in crocodilian research and management, and hopefully some of the techniques that we're using here on alligators can be usable for other species of crocodilians. Because we're using both live and hunter-harvest methods, a lot of what we can do is applicable to other species as well. And so I'm hoping that in the future, I can work with people to help get other projects going to look at things like microplastic or contaminants that are emerging and look at ways of better using crocodilians as indicators of environmental health.
Yeah, because for me it's very difficult to understand when you talk about to determine the contamination with microplastic, because probably many people believe that in America it's not too so contaminate the wetlands, no? It's our idea for the regulation in the United States, you know, and that you are studying this. It's not like Venezuela or Mexico, for example, or probably Belize, that mostly of the trash go to the river or the lagoons, or I don't know. In America, it's happening that in an important percent of the habitats that we have to determine this type of studies?
Yes, definitely. I think what's different about things here is that some of these contaminants, because there's such a large population in the US, and some of these contaminants were used in industry for so long, there's a lot there that we don't see and we just assume has been taken care of by some of the administrative aspects that exist here and also the infrastructure. But for example, for microplastic, it's in almost every water body that's sampled in the US. Because it's so small, there's a lot of systems like water treatment systems or things like that that don't remove it. Same thing for PFAS, forever chemicals. Wastewater treatment plants and other things like that only remove about 10% of what's in there. And then because of the way that things are structured here, things like wastewater treatment plants, which are designed to clean the water, they do, but then all of the solid material that collects on the bottom that's rich in organic material gets repurposed and spread onto farm fields. So then every time it rains, all those contaminants that were taken out of the water system get applied back onto fields and enter our food chain or re-enter the environment. So even in places like the US or Canada or Europe, because of the amount of people and because a lot of these chemicals were used in industry and never regulated before the 1970s or 1990s even, they exist. And because, for example, for microplastic and PFAS, they're contaminants that are very resistant to degradation. Microplastic just continues to break up and get smaller. It doesn't go away. And PFAS are very stable in the environment, so they don't go away. So they're constantly just getting recycled in our wetlands and in our systems. And so by looking at it here and figuring out what ways we can do this and how we can do this effectively and reducing the amount of expense involved with looking at these, it's my hope that we can work to support projects elsewhere and figure out what's there. Because I think we look at everything here and we see PFAS and microplastic in everything. And so it's probably the same everywhere. It's just that some places we haven't had the opportunity yet to get this kind of research going.
Okay. And when you review the stomach content, you found in some of them vegetables?
Yep, almost every stomach.
I ask you because probably you remember my student that made the PhD in Argentina, Samuel, that he implement a diet with soja.
Yep.
And the question is, in wildlife, alligator, you found vegetable in the stomach? Because It's very strange. Or alligators or crocodiles are completely they principal meat animals. No meat.
Right. No, we in almost every stomach that we look at, we find vegetation. Some of that I don't think is eaten on purpose, right? They're trying to get something off the surface, they get some grass or they get some leaves. But there are many alligators that have large pieces of wood in their stomach. They have vegetation, and then in some of them we also find wild fruits. So here in the US we find there's certain trees that have fruits. So we found tupelo seeds and nuts. We found there's a wild kind of grape that grows here. We found muscadine grape seeds and grapes, hawthorn fruits. And so I do think that those ones, when they're on the surface, they look a little bit more like food. And there's been some other papers published that show that crocodilians may eat fruit that could be found in their environments. Whether, there's some smells or something associated with that they like, or it's just another opportunity for some kind of food. We do find that in alligators too.
Oh, great. Well, Miriam, I don't know if you want to say something more in order to finish our incredible conversation about your work.
I think the one thing that I'd say is that crocodilians are amazing and they're so connected to their environment. And so for my project, looking at how they interact with their environment through their diet, so how they connect to the food web, tells us a lot about what's out there in the environment. And then tracking it from diet to contaminants, I think that there's very few other species out there that can show us links to our own health and our own exposure in the environment. They live very similar lifespans to us. They use a lot of the same resources out there that we do. So understanding crocodilian alligator health is really important to looking at what kinds of things out there might impact our health. And so they're just fantastic and they're super important. And so I'm happy that people are interested in studying them and conserving them.
Great. Well, Miriam, thank you very much for your attention. And I hope to see you soon.
Me too.
Okay, and all the best in your study. And we are in touch, okay?
Okay, thanks, Alvaro.
Como pudieron observar en esta agradable conversación con Miriam, hay una contaminación importante, tanto en los cuerpos de agua, en la dieta que se alimentan los cocodrilos, como en los cocodrilos en particular. Pero fíjense que fue bien interesante lo que nos mostró. Ella diseñó un aparato, como pudieron ver en las imágenes, en los videos, para poder hacer el análisis de contenido estomacal. Un aparato que le permite trabajar con mayor comodidad y así obtener todos los restos alimenticios que se encuentran en el estómago de los cocodrilos. Como nos comentó, este estudio está en proceso y esperemos que todos estos resultados le permitan a las autoridades ambientales determinar cuáles son las estrategias para reducir la contaminación de los diferentes cuerpos de agua en la zona donde se encuentran cocodrilos. Espero que haya sido de su agrado este episodio. Es Álvaro Velasco, Cocodrilos del Mundo, por el canal de Río Verde en YouTube. Hasta una nueva oportunidad.